here is mathematical art hosted by Veritas Raymaker, Kenneth Lin. Please touch blue cone, teleport to museum deck. So there are Seifert Surface works. First, this is sculpture, fractal tree, negative curvature fractal. This is a fractal tree that appears similar at different scale. There is a single trunk prim with a number of branch prim. Each level 1 branch prim has its own smaller level 2 branch. Please see this object. Pink prim is similar. So this fractal tree consists by two types of prims. You can read detailed information by touch this box, so you get not curved. And next is equation z equal xy determine a 3D surface called the hyperbolic paraboloid. This doubly rolled surface means that it can be formed as a sweep out of a straight line in two different ways. And this she is a Fibonacci pine cone. And this is a mathematical pine cone. Please see this panel. This is 1, 1, 2, 3, 5, 8, 13, 21. Fibonacci numbers. The Fibonacci number appears natural in pine cone or sunflower or trees. Please look down from sky. There's numbers. Top of pine cone 1 and 2 and 134.5 degree, the number 3, and 139 degree, number 4, and 137.5 degrees golden degree is number 5, and golden degree number 6, and golden degree number 7. The 8, 9, 10, 11, and 12. And you can see spirals. So, for example, you see one spiral, 1, 10, 13, 21, 1, and 2, 3, 4, 5, 6, 7, 8 spiral. So 8 is a Fibonacci number. And another spiral, you can see 8, 13, 18, 23 is one spiral, 2, 3, 4, 5. 5 is also Fibonacci number. And the note card you obtain from a box ask you colors, so red, blue, pink, sky blue, yellow, green, and shading, so white and gray and dark gray. There's some reason, and so note card ask you colors and the shading on this sculpture are related to the numbering. Can you figure out what they mean? So I search information from web, but I got to get the answer. So Next, look up above. This is Hilbert space filling curves. So it is constructed by a limiting process from a sequence of polygonal paths which more and more closely approximate it. This shows the third interaction in the construction of 3D dimension analog. So very interesting. So space filling curves. And more interesting is next one. Please look at this panel. So this is a four-dimensional cube or for 3D projection of four-dimensional cube. Please look left cube. This is usual three-dimensional cube, and we can see this cube through your computer screen. So you see this 3D cube two-dimensional projection. And far side of square is smaller than far side square. Front square and far side square. So far side square is smaller. We can't recognize fourth axis, but we can see number of vertex of four dimension and number of sides and faces. Four-dimensional hypersolid have 16 vertex and 32 sides and 24 faces. And one-dimensional line is made by sweep point, x direction. And two-dimensional square made by sweep line to z-axis. And three-dimensional cube is made by sweep square move to z-axis. Then so maybe four-dimensional hypercube may be made by sweep three-dimensional cube to hyperdirection. But we can see hypercube directly, but we can see 3D projection of hypercube. So this is hypercube. So you can see red cube, the inside of cyan cube. Cyan cube is smaller than red cube. So maybe cyan cube is far from here, from your point. Very strange, but we can see four-dimensional hypercube through 3D projection. And this is Archimedean spiral. Rolled surface can be made by moving a straight line along some path. The surface is swept out by the movement of the line. And go to downstairs. This is a model of a Hopf fibration, which is a remarkable way to define flow lines in 3D dimensional space. The Hopf fibration gives the first known example of a non-trivial ninth homotopy group of the m-dimensional sphere with n greater than m. which was very surprising at the time. So, very beautiful. I don't know, we can see this shape in nature. So, magnetic field or something, but I don't know. And go downstairs. Both are torus knots. Torus knot is not that lines on the surface of a torus. Torus is donut shape, and we touch this blue cone. Next, we will see Escher's relativity. We can enjoy the art of mathematics, but such information of the shape is more interesting. Fibonacci pine cone also have very deep information, and it is exciting. And come on, please. The Cheaton ball. There is many sting ball. Red, green, and blue. Yeah. So please ascend and descend these stairs. And for example, this ball touch and you get basket. Basket. And she it here. It's my interesting. And another is wine tray. So touch that ball and you can carry a wine tray.